Hello friends, in this chapter linear programming problem we have seen how to find out the solution set of linear equation and linear inequation graphically. Even we have seen some important definition related with linear programming problem, that is definition of constraint, objective function, convex set, feasible solution, feasible region, how to solve the linear programming problem graphically. Using all these results, we are now starting the example from Miscellaneous Exercise. So all of you are most welcome to my YouTube channel Maths by Samit Deshmukh. See, in the first example, so question number first is nothing but what? Objective type question. In question number first, we have to find out the value of objective function is maximum under the linear constraint. Means the value of objective function is maximum under the linear constraint. So what is first option? At the center of feasible region. Already we have solved the linear programming problem graphically, and in that case already we have seen that the objective function is maximum or minimum where? At the vertices of convex polygon. Means definitely first option will not be the answer. At the center of a feasible region, we have not seen how to find out center of a feasible region. So at origin it is also not possible. Definitely we know that the function is maximum or minimum at what? At the vertices of feasible region. So this will be the correct option here. Now observe the second example. Which of the following is correct? So check the first option. Every linear programming problem has an optimum solution. So here, see, when we are able to solve the linear programming problem, if feasible region exists. Sometimes feasible region does not exist. When it does not exist, suppose that these are two constraints, and if first constraint says that origin side part will be the solution set, and second says that non-origin side part will be the solution set, means there is no common region or not set of points satisfying all the constraint, means feasible region does not exist. If feasible region does not exist, at that time linear programming problem cannot be solved. So here they are saying that every linear programming problem has a optimum solution. It is not possible. Sometimes linear programming problem does not solve if feasible region does not exist. A linear programming problem has unique optimum solution. So no, sometimes a linear programming problem has maximum solution. Try to understand when a linear programming problem has maximum solution. Let us suppose that some constraint are given to us, and using that constraint, we have got this will be say feasible region. Okay, and let us denote this vertex by A and this vertex by what? B. Suppose that the maximum value of objective function at vertex A is 25 and maximum value of objective function at vertex B is also 25, and at remaining vertices value of objective function is less than 25. In such cases, what we can say that therefore maximum optimum solution is 25. We are not writing at vertex A and at vertex B. If we are getting maximum optimum solution or minimum optimum solution at 2 points, at that time our answer is, so therefore linear maximum optimum solution of linear programming problem is 25 at all the point lie on this segment AB. At all the point lie on this segment AB, and on this segment AB how many points are there? Infinite points are there. So in such cases we can say that a linear programming problem has maximum has infinitely many solution. Means sometimes linear programming problem has what? Infinitely many solution also. So that's why we cannot say that every linear programming problem has unique solution. If linear programming problem has two optimum solutions, just now we have discussed that if it has two optimum solution, then it has infinite number of optimum solution. Yes, if it has two optimum solution, at that time we can say that it will have infinitely optimum solution, and that optimum solution lies at every point on what? This segment AB. If you are able to check it by some example also. So now the set of all feasible solution of a linear programming problem may not be a convex set. Already our first theorem in this chapter says that the feasible region of a linear programming problem is always what? Convex set, and they are saying that it is not a convex set, so it is also not true. So that's why here we can say that C option will be the correct answer. If we are getting optimum solution at 2 points, so we can say that the linear programming problem has infinite optimum solution, infinite number of optimum solution at every point on this segment AB. See the example number 3rd. In example number 3rd, objective function of linear programming problem is, already we know the definition of objective function. Objective function is a function which is to be optimized. Optimize means to be maximized or to be what? Minimized. So let us check which option satisfies this condition. Objective function is a constraint. It is not possible. Is a function to be maximized or minimized? Here this condition is satisfying, but let us discuss on remaining option also. It is a relation between decision variable. So relation between decision variable is also called as what? Constraint also. So we cannot say that it is objective function. Equation of straight line, definitely it is not a equation of straight line. It is a function which is to be optimized, means to be maximized or to be minimized. So B option will be the correct answer. Now in example number 4, we have to find out the maximum value of this objective function subject to the constraint. So in such cases, a lot of practice will be required. So these are time consuming example. We does not have any shortcut method to solve such type of example. So you should have to construct a graph, rough sketch of a graph, and you should have a practice to find out coordinate of the vertices of the feasible region and substitute these coordinate of feasible region in objective function to find out its maximum optimum solution or minimum optimum solution. So here x is greater than or equals to 0 and y is greater than or equals to 0 is given to us, means solution set lies in first quadrant. Let us try to find out coordinate of 2 point on this line. So if I am substituting y is equal to 0, so 3x is equals to 15 means x will be equals to 5, replace x by 0, so 5y will be equal to 15 means y will be equals to 3. So 2 point on the line first are known to us. Let us try to find out coordinate of 2 point on the line second. If I am substituting y is equal to 0, x will be equals to 2. If I am substituting x is equals to 0, 2y is 10 means y will be equals to 5. So coordinate of 2 point on the line are known to us. Draw a line passing through these 2 points. So try to understand, this will be what? Rough sketch here. So let us try to construct the first line. So first line passes through the point 5, 0 and 0, 3. So passes through these 2 points. Second line, so this equation of this line is 3x plus 5y is equals to 15. Now second line passes through the point 2, 0 and 0, 5. Means this will be our second line. So here equation of line is what? 5x plus 2y is equals to 10. So in both the constraint less than or equals to is there, means we can say that for both the line origin side part will be the solution set. Denote its vertices by a, b, c and o. Here coordinate of vertex a are 2, 0, coordinate of vertex c are 0, 3, coordinate of origin are 0, 0. To find out coordinate of point b, we have to solve these two equations simultaneously. So here if I am multiplying by 2, let us see what we'll get here. If I am multiplying by 2, here we'll get 6x plus 10y is equals to 30. If I am multiplying here by 5, so that coefficient of y will become what? Same. So multiply by 5, 25x plus 10y is equals to 50. So now if we are taking difference of these two equations, 25 minus 6 will be equals to 90x, 10y will get cancelled, 50 minus 30 will be equal to 20. So x will be equals to 20 upon 19. So x coordinate is 20 upon 19. Now let us try to find out value of y coordinate. Substitute this value of x in any equation. Let us substitute this value in this equation. So what we will get here, if I am substituting substitute this value in this equation, x is equal to 20 by 9. 20 into 3 60. 60 by 19 on this side will become minus 60 by 19. So remaining term will be 5y is equal to 15 minus 60 by 19. So all the terms are divisible by 5. If I am dividing both sides by 5, here we will get y, here we will get 3, here we will get 12. 12 upon 19. 19 3s are 57. 57 minus 12 will be 45. 45 upon 19 will be the value of what? 45 upon 19 will be the value of y coordinate. Now objective function is given to us. Let us try to find out value of this objective function at all these vertices. At point C, its value is equal to 3 into 3 is 9. 9 does not appear in this option. Again 2 comma 0 means replace x by 2. 2 into 5 is 10. 10 does not appear in this option. Means definitely our maximum optimum solution is at vertex B. So let us try to find out value of objective function at vertex B. So replace x by what? X by 20 by 19. 25 is a 100. So I am substituting 20 by 19. Value of x is 20 by 19. So 25 is a 100. 100 upon 19. So plus, now I am substituting y is equal to 45 upon 19. 45 3s are 135. So 135 upon 19. So which is equal to, what will the addition? 235 upon 19. So 235 upon 19 will be our correct answer. Means here you are to spend some times to draw the rough sketch to find out the vertices, then substitute the value in the objective function to find out maximum or minimum optimum solution. Now see the question number 5. In this question, the maximum value of z is equal to 10x plus 6y subject to these constraint is, means we have to find out maximum value of objective function. And we know that while finding maximum value, we have to solve the equation what? We have to solve this linear programming problem graphically. So here shortcut methods are not there, but you are able to use some skills. You try to develop such skill so that easily you are able to solve this example. Okay, so now try to find out coordinate of 2 point on the line first. So coordinate of 2 point on this line first are. So if I am substituting y is equal to 0, x will be equals to 4. If I am substituting x is equal to 0, y will be equals to 12. And coordinate of 2 point on the line second are, if I am substituting y is equal to 0, 2x is 34 means x is equal to 17. And if I am substituting x is equal to 0, 5y is equal to 34 means y is equal to 34 upon 5 means it will be 6.8. So now remember that. So better way first we will spend some time to solve this example so that easily you are able to understand the shortcut methods. Okay, so here our line first passes through the point. So 2, 4, 6, 8, 10, 12, 14, 16, 18, because coordinate of one point is what? 17 comma 0 if you observe here. And here also take 2, 4, 6, 8, 10, 12, 14, 16. Okay, now first line passes through the point 4 comma 0 and 0 comma 12. चलो अब अच्छी तरीके से समझने की कोशिश कीजिए यहाँ पे. एंड सेकेंड लाइन पासेस थ्रू द पॉइंट 17 comma 0 and 6.8 lies somewhere in between 6 and 8. So our second line passes through these 2 points. And for both the line, which part is the solution set? Origin side, because if you observe here less than are there. Is it clear? अभी यहाँ पे अगर आपको ग्राफ नहीं ड्रॉ करना है और आंसर फाइंड करना है तो कैसे सोचना है. चलो अभी अगर लेस देन में ये जो दूर के पॉइंट होते हैं एक्स एक्सिस के ऊपर के दूर के जो पॉइंट है, दैट डज नॉट बिलोंग्स इन व्हाट वर्टाइसेस ऑफ दिस फिजिबल रीजन. यानी कौन सा, अभी ये एक्स एक्सिस पे के पॉइंट कौन से 17 comma 0 एंड 4 comma 0, तो ये पॉइंट नहीं आएगा. अगर फिजिबल सोल्यूशन ओरिजिन साइड है तब की बात कर रहे हैं हम. एंड वाई एक्सिस पे दूर कौन आ रहा है? ये पॉइंट आ रहा है. सो दिस पॉइंट विल गेट इलिमिनेट. गेटिंग इट? Okay, so two vertices are known to us. Which two vertices? 4 comma 0 and 0 comma 6.8. Let us check whether our objective function get maximize or minimize at this point, because options are in front of you. If I am substituting value of x is equals to 4 into 10 will be 40. 40 does not belongs to our options, means this will be the wrong answer. So let us check whether what value we are getting if we are substituting this value of x and y here. Here 6 into 6.8, its value is in between what? We can say that its value is in between 36 and 42, because this value lies in between 6 and 7. 6 6 are 36 and 7 6 are 42. तो ये वैल्यू अगर 6 और 7 के बीच में है तो हमारा आंसर भी कहाँ पे आएगा? 36 और 42 के बीच में आएगा. एंड देयर इज नो वैल्यू विच इज इन बिटवीन व्हाट? 36 एंड 42. इसका मतलब ऑब्जेक्टिव फंक्शन ये दोनों पॉइंट पे, यानी ये दोनों वर्टाइसेस पे मैक्सिमाइज या मिनिमाइज नहीं हो रहा है, मैक्सिमाइज नहीं हो रहा है. जिस नाइट एग्जांपल इज रिलेटेड विथ व्हाट? मैक्सिमाइज. तो ये दोनों पॉइंट में मैक्सिमाइज नहीं हो रहा है, इसका मतलब ये पॉइंट ऑफ इंटरसेक्शन पे ही मैक्सिमाइज हो रहा है. तो आपको क्या करना है? ये दोनों इक्वेशन सॉल्व करने हैं, ये ग्राफ ड्रॉ करने की जरूरत नहीं है. यू आर गेटिंग इट? ये एक्स एक्सिस और वाई एक्सिस के ऊपर के कौन से पॉइंट वर्टाइसेस हो सकते हैं, ये तो आपको समझ में आ गया. लेस देन अगर रहा तो ये दोनों पॉइंट है एक्स एक्सिस के ऊपर के, दूर के पॉइंट छोड़ दो. गेटिंग इट? यूज द सेम मेथड इन केस ऑफ वर्टाइसेस ऑन वाई एक्सिस. वर्टाइसेस कौन सा होगा? दूर का पॉइंट छोड़ दो. अब ये 12 दूर है कंपैरेटिवली टू व्हाट? 0.6.8. तो ये 0.6.8 इज द वर्टेक्स ऑफ आवर फिजिबल रीजन. इज इट क्लियर? अब ये जो पॉइंट है, ये दोनों पॉइंट पे तो आपको पता चला है, ग्राफ भी आपने ड्रॉ नहीं किया, ये दोनों पॉइंट पे तो हमारा ऑब्जेक्टिव फंक्शन मैक्सिमाइज नहीं हो रहा है. इसका मतलब ये दोनों के पॉइंट ऑफ इंटरसेक्शन पे ही मैक्सिमाइज होगा, क्योंकि और कोई पॉसिबिलिटी है नहीं, ओरिजिन पे तो मैक्सिमाइज नहीं हो सकता. Okay, so solve these two equations simultaneously. So here LCM of 2 and 3 is 6. तो मैं इसे 6 लाने के लिए 2 से मल्टीप्लाई करूंगा. So what we'll get here? 6x plus 2y is equals to 24. If I am multiplying here by 3 to get 6 here, multiply by 3. So here we'll get 6x plus 15y, and if I am multiplying here by 3, we will get 102. 34 3s are, yes, 102. Take the subtraction. 6 minus 6 will get cancelled. Here 15 minus 2 will be equals to 13y, and 102 minus 70 minus 24 will be 78. 13 6 are 78, means y coordinate is known to us 6. Substitute this value of y is equal to 6 in any equation. 6 on this side will become minus 6. 12 minus 6 will be equals to 6, and 3x is equal to 6 means x is equal to 2. So once the value of this coordinate are known to us, definitely our objective function will get maximized at this point, क्योंकि ये तीनों पॉइंट तो पहले ही चेक कर चुके हम. So 2 and 6. If I am replacing x by 2, so here we will get 20, and if I am replacing y by 6, 6 6 are 36. 20 plus 36 will be equals to what? 56 will be our correct answer. Getting it? होप द आइडिया इज वेरी क्लियर टू यू. अभी अगर मैक्सिमाइज के जगह पे मिनिमाइज होता था तो कौन से टर्म कैंसिल होते थे? तो मैक्सिमाइज के मिनिमाइज, और यहाँ पे इन केस ऑफ मिनिमाइज यहाँ पे ग्रेटर देन दिया जाता है. जब ग्रेटर देन है तो ये पार्ट सॉल्यूशन सेट होगा. ये पार्ट अगर सॉल्यूशन सेट हो गया तो एक्स एक्सिस के ऊपर का पहला पॉइंट फिजिबल सॉल्यूशन का वर्टेक्स होगा या सेकेंड पॉइंट होगा, ये आपको आइडेंटिफाई करना है. तो अगर ये पार्ट सॉल्यूशन सेट अगर रहा तो फिर कौन सा पॉइंट आएगा? ये जो दूर वाला पॉइंट है. मीन्स व्हाट? 17,0 will be the vertex, and here which will be the vertex? This point will be the vertex. If non-origin side part will be our what? Solution set or feasible region. So try to understand without constructing the graph how to solve this example. Now observe the next example. The point at which the maximum value of this objective function x plus y subject to this constraint is obtained at. In this case, if you'll observe the example very carefully, so if you'll observe the options in any option point on x-axis and y-axis does not appears. तो उन्होंने क्या किया, ये जो एक्सिस के ऊपर के जो वर्टाइसेस है वो ऑप्शन में दिए ही नहीं. इसका मतलब क्या हुआ कि कौन से पॉइंट पे ऑब्जेक्टिव फंक्शन मैक्सिमम होने वाला है, एट द पॉइंट ऑफ इंटरसेक्शन, क्योंकि यहाँ पे नॉट इन अ सिंगल ऑप्शन, एक्स कोऑर्डिनेट इज आल्सो नॉट जीरो, मीन्स पॉइंट ऑन वाई एक्सिस आर नॉट गिवन, एंड सिंस वाई कोऑर्डिनेट इज आल्सो नॉट जीरो मीन्स पॉइंट ऑन एक्स एक्सिस आर आल्सो नॉट गिवन, मीन्स डेफिनेटली दिस ऑब्जेक्टिव फंक्शन गेट मैक्सिमाइज एट व्हाट, एट द पॉइंट ऑफ इंटरसेक्शन ऑफ दिस टू लाइन्स. अब दो ही लाइन है तो इनका पॉइंट ऑफ इंटरसेक्शन निकालो. पॉइंट ऑफ इंटरसेक्शन मीन्स व्हाट, it is the point lies on line first also and line second also. So means point, if two line intersect, how many point of intersection are there? Only one point of intersection are there. Since this point lies on first line, so its coordinate satisfies equation of first line. Since it lies on second line also, so its coordinate satisfies second equation also. Let us check which coordinate satisfies both the equation. Substitute this value in the first equation. X is 30 and y is 25. 25 to the 50, 50 plus 30 is not equal to 70. Means this option does not satisfy first equation. Here 20 and 35 to the 70, so their addition will be 90. So this equation is also not satisfying by coordinate of this point. Let us check by the coordinate of this point. If I am replacing x by 35 and y by 20, 22 is 40, 40 plus 35 is 75, and on this side 70 is given, so this equation is also not satisfying. Let us check whether coordinate of last point satisfies both the equation or not. Replace x by 40 and y by 15, 15 to the 30, 30 plus 40 is 70, means it satisfies first line. Let us check it satisfies second line or not. 40 to the 80, 80 plus 15 will be 95, means this point satisfies both the equations, so that's why we can say that this will be our required answer. यहाँ पे क्या किया है उन्होंने समझ में आ गया. आपको एक्स एक्सिस और वाई एक्सिस पे लाई होने वाले वर्टाइसेस दिए ही नहीं है. इसका मतलब क्या हुआ कि our objective function get maximize at what point of intersection, but only two constraints are given to us, and this constraint says that what solution set lies in what first quadrant. इसका मतलब हमारा ऑब्जेक्टिव फंक्शन इनके पॉइंट ऑफ इंटरसेक्शन पे ही मैक्सिमाइज हो रहा है. जस्ट आवर एम इज टू फाइंड आउट कोऑर्डिनेट ऑफ दैट पॉइंट ऑफ इंटरसेक्शन. अगर ऑप्शन ऐसा होता था तो आपको ये कोऑर्डिनेट फाइंड ही करने पड़ते थे बाय सॉल्विंग दीज टू इक्वेशंस साइमल्टेनियसली. See the example number 7th. In this example, of all the points of the feasible region, the optimum value of z obtained at a point lies. Now optimum value of the objective function, z means what? Objective function, and we know that optimum value of objective function is at vertex of the feasible region. So let us check which option will be satisfying here. Inside the feasible region is wrong, at the boundary of the feasible region is wrong, because we know that on a boundary infinite points are there, and it is not possible to substitute the values of infinite points, coordinate of infinite point in the objective function. Our convex polygon theorem says that the optimum value lies at what vertex, so at the vertex of the feasible region. So this will be the correct answer here. Now see the example number 8. In this example number 8, what is the question? Feasible region is the set of point which satisfies what? All the constraint. Feasible region is the set of point which satisfies all the constraint in the example. So here the objective function is wrong. All the given constraint is the correct answer. Some is wrong. Only one it is also wrong. It is the region, or it is the set of point which satisfies all the constraint, and which is called as feasible solution, and that region is called as feasible region. Now see the example number 9. Solution of linear programming problem. Minimize z is equal to 2x plus 3y such that x is greater than or equals to 0, y is greater than or equals to 0, x plus y is greater than or equals to 1, and less than or equals to 10 is. Now we have to check at which point the value of this objective function minimize subject to this constraint. Meaning of first two constraint is what? Meaning of first two constraint is what? solution set lies in the first quadrant. Now observe the next constraint. If you will observe the next constraint, what is first line? X plus 2y is equals to 1, and here x plus 2y is greater than 1, means for this constraint non-origin side part will be the solution set. 2 point on this line are, if I am substituting y is equal to 0, so x will be equals to 1, and if I am substituting x is equal to 0, 2y is equal to 1, means y is equal to 1 by 2. And second line is x plus 2y is equal to 10. If I am finding point on x-axis, substitute y coordinate 0, so if y term of y becomes 0, x will be equals to 10, and if I am substituting x is equal to 0, 2y is equal to 10 implies that y is equal to what? 5. Means rough sketch of this will be somewhat, this first line passes through the point 1 and 1 by 2. So this will be the rough sketch of first line, and this will be the second line which passes through the point 10 comma 0 and 0 comma 5, means this will be the rough sketch of second line. So for second line origin side part, for first line non-origin side part, means this will be the feasible region here, and these points are nothing but vertices. So all these points are nothing but vertices. Let us check what will the value of this objective function at first point. If we are substituting coordinate of this point, so 2 0 means 2 will be the value of objective function. Here if I am substituting 0 and 1 by 2 in, means x coordinate is 0 and y coordinate is 1 by 2 in objective function, first term will become 0, and 3 into 1 by 2 will be equal to 1.5. At this point value of objective function will be 20, because 10 2s are 20, and at this point value of objective function, replace x by 0 and y by 5, 5 3s are 15. So at this time we have to minimize the given objective function. So minimum optimum solution is 1.5. Here if you will observe all these values which we are getting at x is equals to 0 and y is equals to 1 by 2. See, in the example number 10, we have to find out corner point of the feasible solution given by these inequations. Means here we have to find out vertices of the feasible region. Corner point means what? Vertices. So for the first line, x plus y is equal to 4. Here if we are substituting y is equal to 0, x will be equals to 4, and if we are substituting x is equal to 0, y will be equals to 4. 2 point on this line are known to us. Second line is 2x plus y is equal to 7, so which passes through the point. If we are substituting y is equal to 0, x is equal to 7 by 2, x is equal to 7 by 2 means 3.5, and if I am substituting x is equal to 0, y will be equals to if we are substituting x is equals to 0, y will be equal to 7. Whenever in the constraint all the terms are, all the signs are less than, so meaning of these two constraint means what? Solution set lies in the first quadrant, and in remaining constraint less than is there, at that time which point on x-axis belongs to vertices which will be very close to origin. So if you will observe, these are 2 point on x-axis. So 7.2, 7 by 2 means 3.5. So 3.5 is less comparatively to this. So this cannot be the vertices. And if you will compare here, these are 2 point on y-axis. So this is very close to origin. So this is not the vertex, isn't it? अगर ये इस टाइप के अगर दो लाइंस है, तो फिर अगर ये ओरिजिन साइड पार्ट अगर सोल्यूशन सेट है, सो विच पॉइंट बिलोंग, विच आर द पॉइंट्स ऑन एक्स एक्सिस एंड वाई एक्सिस which can be considered as vertices which are very close to what? Origin. And next vertex is point of intersection of these two lines and what? Origin. So let us check here, these point appears in which option? So origin appears in all the option, isn't it? So again 0 comma 4 appears only in these two options, so these two are wrong option, isn't it? Again 7 by 2 comma 0 appears only in this option, so here 7 by 2 does not appear, so this will be the wrong option. But till we are doing the practice, so let us check whether this is the point of intersection of these two lines or not, because already these two are our required vertices and origin also our vertex. Only to check whether this fourth vertex is 3 comma 1 or not, which is nothing but point of intersection of these two lines. Yes, 3 and 1. So satisfies first equation. If I am replacing x by 3 and y by 1, 3 plus 1 is 4, 4 is equal to 4. Means left hand side is equal to right hand side. Let us check whether coordinate of this point satisfies this equation or not. 3 into 2 is 6, 6 plus 1 will be equal to 7. So yes, so B option will be the correct answer here. So these points are nothing but vertices of the feasible region. See, in the example number 11, the corner point of the feasible solutions are given to us. Then z is equal to 7x plus y, means this objective function is maximum at which vertex the objective function is maximum, that we have to find out here. So definitely objective function cannot be maximum at 0. So let us try to find out value of objective function at what? 2 comma 0. Here the value of objective function is 2 7s are 14, means here we are getting 14. So let us try to find out value of objective function at this point. At this point its value is x is 0, y is 1, means 0 plus 1 will be equal to 1. Now let us try to find out value of this objective function at this point. At which point? 12 by 7 and 3 by 7. If I am substituting here value of x is equal to 12 by 7, 7 will get cancelled. What we will get here? 12 plus 3 by 7. So 3 by 7 is definitely less than 1, means our approximate value will be 12 point something. 12 point something is definitely less than what? 14. So here we can observe that the maximum value which you are getting is what? At which point? 2 comma 0. In the example number 12 also, the corner point of the feasible solutions are given to us, and we have to check at which what is the maximum value of this objective function. So definitely maximum optimum value cannot lies at what? Origin. May be possible that minimum value may lies, but maximum value cannot lies at what? Origin. So let us try to find out value of this objective function at this vertex. So replace x by 3 and y by 0. So here we will get 12. Substitute the coordinate of second point 2 and 1. So here replace x by 2, 2 4 is 8 and 1 into 5 is 5. 8 plus 5 will be equals to 13. 13 is the value of objective function at this vertex, and at this vertex let us check what value we are getting here. If I am substituting x is equal to 0, first term will become 0, and here 7 5s are 35. 35 upon 3. 35 upon 3, its approximate value is 11 point something, isn't it? So 11 point something is definitely less than by what? 13. So means here we can observe that the maximum optimum solution is how much? 13, which we are getting at which vertex? 2 comma 1. So in the example number 13, the corner point of the feasible solutions are given to us, and we have to find out, then we have to check the minimum value of this objective function lies at which vertex. Minimum value. So minimum value here, check what is the value of this objective function? 20, because x is 0 and y is 10. So 10 into 2 will be equal to 20. Here we are getting 20. If I am replacing x by 2, 2 3s are 6 and y by 2, 2 2s are 4. Means 6 plus 4 will be equal to 10. If I am substituting the coordinate of next vertex, so replace x by 4, 4 3s are 12 plus 0, means here we are getting 12. So here we can observe that the minimum value which we are getting is what? 10, which is at which point? 2 comma 2, means at this point the value of this objective function is minimum. Now see the example number 14, the half plane represented by this constraint contains the point. Here less than is there. Less than is there means easily we can say that origin side part will be the solution set. So here origin is given to us, means definite as the coordinate of origin satisfies this equation. So that's why we can say that origin side part will be the solution set. और भी बहुत से पॉइंट दिए हैं, लेकिन कोई तो भी एक ही ऑप्शन करेक्ट होने वाला है, तो बाकी की चेक करके देखने की जरूरत ही नहीं है, because origin side part will be the solution set and origin is given here. If origin is not given, at that time we have to check that which point satisfies this constraint, but origin is given, so not necessary to take the efforts here. Now the half plane represented by this constraint contain the point. So here greater than is there means definitely non-origin side part will be the solution set. So since non-origin side part is solution set, so this option is not correct answer. अगर non-origin है तो origin से ज़्यादा दूर जिसके कोऑर्डिनेट होंगे या जिसके बड़े कोऑर्डिनेट होंगे जिस पॉइंट के, वही ये कंस्ट्रेंट क्या कर सकता है, सेटिस्फाई. बट एज वी आर डूइंग प्रैक्टिस, लेट अस चेक बाय एवरी ऑप्शन. इफ आई एम रिप्लेसिंग x by 2, here we will get 8, y by 2, so here we'll get 6. 8 plus 6 is 14. 14 cannot be greater than 14, so this point does not satisfy this condition. If I am replacing x by 1, here we will get 4, y by 1, here we will get 3. 3 plus 4 is 7, is not greater than 14, so this option is also wrong option, means definitely this is correct answer. Let us check it. Replace x by 3, 3 4s are 12. Replace y by 4, 4 3s are 12. 12 plus 12 is what? 24, and 24 is greater than what? 14. So coordinate of this point or the half plane lies on the side of this point. So half plane represented by this constraint contain this point. So in this way we have completed objective type questions of linear programming problem. In the next video we will discuss remaining example from this miscellaneous exercise.